Hi, this is for number 2 and for number 3, both in the same video. Number 2 wants you to get 5 different concentrations and 5 different absorbances with a fixed wavelength setting. I know there's only one blank here for concentration and absorbance, but they really want 5. So you need to give me 5 points of data, and here's how to do that. You go to the lab, and then you just pick one, like for example, just like that one, whoops, like that one, like that one. 17 millimolar, 0.09 absorbance. That's a data point. You write that down, you know? And maybe like, like that one. 85 millimolar and 0.45 absorbance. You write that down. And you just do this 5 times. 155 millimolar, 0.82 absorbance. You write that down. 277 millimolar, 1.47 absorbance. You write that down. You see what I mean? Now, once you know how to get the data, it's useful to write down that data on the computer rather than on paper because you have to upload your work for me anyways. Here, let me show you a convenient way to do that. You could use Microsoft Excel or OpenOffice Calc if you like, but all of you, I know, would have access to Google Drive because you have a Google account because the Portmont account is a Google account. Well, anyways, if you go to your Google Drive and then you click on New and then you click on Google Sheets, then you will see something that looks like Microsoft Excel. It's very similar. Here you can type concentration and you can type absorbance, and then you can just go on your merry way typing in the data that you got. See, now you don't have to write it down. You can just type in the data. So, I can just type in oops, I can type in 277 1.47. Know what I mean? 277 millimolar 1.47. All right, and you just keep on doing that until you have 5 pieces of data, 5 points of data. And let me show you what that will look like. There you are. This is my sheet, and then you see that I have 5 pieces of data there. Now, that's what you do for number 2. You can download this as whatever file type you want. Any of these is fine. And then you could upload that file to your homework for me to check. That will be your number 2. You need to have concentration and absorb. Oh, there's one more thing. You need to have the units. Concentration in millimolar and absorbance. Absorbance doesn't really have units, but you could just call it A. The reason why you can just call it A is because the lab calls it A. Oh, I guess they don't call it A. Oh, well, most textbooks call it A. But anyways, I'm not going to be picky about the units for absorbance, but I am going to be picky about the units for concentration. Whether it's micromolar or millimolar, there needs to be units there. If you're doing something where the concentration was a micromolar, you can just put a U there, UM. That's usually short for micromolar. The U is supposed to be the Greek letter mu, but it's hard to type the Greek letter mu on your keyboard, so U is fine for us. Anyways, mine is millimolar. Okay, so that's number 2. Now, for number 3, you can sketch the graph by hand, but it's much easier to have the Google Drive software sketch the graph for you. Because if you sketch it by hand, you have to take a photo, and you have to upload the photo for me on the homework, and it's kind of a drag. But if you just tap on the Insert menu on Google Drive and then insert a chart, oh, sorry, before you do that, you need to highlight your data. Whoops, okay, there it is. I've highlighted all my data, and now I tap on Insert, and then I tap on Chart, and then it's very important to select the scatter chart. You could have big dots on it or little dots on it. I prefer little dots, but whatever you want, whatever that would work. Looks like for my data, the bubble chart won't work, but the little dots will work. So this is what I use, and then that's the sketch of my graph. Now there's a little something extra that I'd like you to try along with the sketch of your graph. If you go to Customize, of course the chart needs a title, so you can title it some appropriate name. For me, nickel chloride, nickel 2 chloride absorbance would be appropriate. For you, I hope it will be something else. And then for the horizontal axis, for me, the horizontal axis was concentration in units of millimolar, and the the vertical axis, here we go. It's just a drop-down box. I can do the vertical axis. The vertical axis was absorbance, right? There it is. So you see that titles are appearing here. It's very important for your graph to have titles. And then let's see, the extra thing here is the trend line. So you can see that my data looks like it is occupying a line. So if I were to connect the dots, it's about a line, right? Well, you can choose that on trend line. You can choose linear, and then that will draw a line there for you. And that line is the best fit line for all of these points. It's not just connecting the dots, but it's connecting the dots in such a way so that that line goes through the dead center of as many dots as possible, or gets as close as possible to dead center of as many dots as possible. If you click on Show R Squared, let me show you that to move this window over. This R squared is 1. That's because this is not a real lab, this is a virtual lab. When the R squared is 1, that means your dots are in perfect alignment with the type of trend line that you selected, in this case, a straight line, linear. Usually, the R squared tends to be something less than 1, like 0.9 or 0.8. The closer the R squared is to 1, the truer it is that your dots here, the relationship of your data, is linear. They fall on a straight line. A very nice bonus feature here is that if I hover, if I just mouse over the line, not the point, but just the pointless part of the line, you can see I get an equation. That equation is the equation for this line. You can see that it's the same equation wherever I go. It's y equals 5.318e minus 3 times x minus 1.043e minus 3. It's always that. The boldface number is just the x and y coordinate of where I'm mousing over, but the equation is always the same. You know what that equation is? That's y equals mx plus b, the equation of a line from your algebra class. That's just y equals mx plus b. So using that equation, you can predict, just by solving for x or solving for y, what the absorbance would be for any concentration. So, for example, at 150 millimolar, I can use that equation to predict that the absorbance would be 0.794917726. Do you see that? Oh, sorry. Where is it? I see. So it's not, so at 150 millimolar, I just have to plug in 150 for x, and then solve the equation for y, and that would be the absorbance at 150 millimolar. The boldface numbers there, 149.66666667, that's not quite 150. But the way the computer, the way the software got the y coordinate there, 0.794917726, it got it by using the equation y equals 5.31 e minus 3 times x minus 1.043 e minus 3. So that's a cool thing. That's a cool application of y equals mx plus b from your math class to this cool chemistry lab. So anyways, I click on insert to insert the sketch of the graph, and then as the answer for number 3, I can just upload this. So I will click on the file menu and then download as whatever I want, because Glenn can open your file regardless of what kind of format it is. Any of these formats will be fine. And then that's it for number 3.